Hello everyone and welcome to COVID-19 social distancing simulation. We're here in Greenfoot and in our game you'll be able to run the population and put in how many people you want. And then you can also choose whether you want to social distance or put a mask on each of the people, and that will decrease their infection radius, and the social distancing will keep them away from each other. So if I run it with nothing being changed, they will infect very quickly. But if I put social distancing on and a mask, the infection slows significantly. And you'll see in the video an example where when I put this in from the start, they won't infect basically anyone. And you can see the green signifies that they've recovered. Um, and so I want to give credit to channel Greenfoot on YouTube. They were the first ones to make a coronavirus type game, but I used that idea a little bit and I expanded on it by creating a social distancing radius and an infection radius, whereas theirs is just touching somebody and they don't really do social distancing. They just stop the players from moving. Within Greenfoot, there is a text editor that we will use. We will write Java code and perform different tasks using if statements, lists, loops, and many other programming techniques to complete our simulation. So I hope this simulation can show the impact that social distancing and having proper protective equipment can have in combating the virus. And I hope you guys enjoy the video. Let's go ahead and get started. If you're new to Greenfoot, you need to go to greenfoot.org so you can download Greenfoot for the first time. And so if you click on the software, and Greenfoot's great because it can be run on any operating system, and you can even have it as a standalone and put it on a flash drive and run it through that. And so really it's able to be run anywhere. And when you first open up Greenfoot, you'll see a screen either like this or with no background. I would go ahead and just create a new Java scenario. We can call it COVID-19 social distancing simulation. Okay, and once you have your screen, Greenfoot is great because these classes are pre-made and you can access them, as well as create your own subclasses of those, and you're able to attach images very easily with that. So first thing you can do is right click on your My World and change the background. And I really like sand 2. That's the second bit that looks like sand. It's quite a bit lighter right there. And it makes for a nice even background. That's bright enough that we're going to use darker images, and so make it a little easier to see. And then we can change the size. And so if you double click or right click and open editor, Greenfoot will give you this code editor that you can use, and it's written entirely in Java. And so it makes it very easy to transition if you've practiced with Java before. And so the size that I will use, I'll do 1200 by 600 and see what that looks like. Different monitors will have different sizes available, and this is exactly the size that we want. So we're set up and good to go. Now, if we're trying to get people on the screen, they need to have behaviors and and create actors. Our world will be our background and the environment in which our players do things in. And so we need to right click on our actor. Our My World has already been named as our subclass of world, and so that's what we double clicked on before. Right click new subclass of actor, and we can call this person. Okay, and so this person, oops, I need to give an image to as well, so you can set image, and you can go to people, and we can just give them this person. Now, this person is actually a little bit too big. We're going to be able to manipulate between 0 and a few hundred of these images on the screen, and so we want to make sure that that image is a lot lower. So we're going to write our first code here. And so in order to affect behavior onto each one of our persons objects in our world, we are going to need to create a constructor. A constructor will allow us, so you just do public and the name of the class. We've named ours person. And so now we can do things that will happen before the run button is executed. Okay, and so our act method, we'll talk about that here in a second, will happen when the run button is executed, but this will happen before. And what we're going to do with the constructor is we're going to access all of its different image functions that it can have, because our person extends actor, meaning it's a subclass of actor. So it accepts all of the actor methods, as well as inside of the actor you can do get image. If you just do control space, it'll come up with this awesome list of different things that you can access, different functions that this has. So one of the things that the actor class has is a get image, which it gets the Greenfoot image, which is also another class that we're going to access. So if you do get image dot and then control space one more time, you can see all the methods that the Greenfoot image class has. By doing get image, we can do scale, and scale, if you look at that, it says it needs a width and a height, so it needs a couple parameters. So our width is going to be 40 and our height is going to be 40. Now there's no way it would be able to scale this without a width and a height, so it requires just a width and a height numbers, integer values in there, so it knows how much to scale it, and that's based off the number of pixels. Okay, so if I refresh this, you can add a person in by holding shift down and clicking in. You can also right click and click new person and add them in that way. Okay, and if we needed to change that later, simple as changing the scale. Okay, so now that we have our players, we want to have them do a little bit of movement here. Okay, and so first and foremost, you can just do a very simple move by putting in a number. Now, the way you can find stuff like that, you can do control space, and there's a bunch of different functions the actor class already has. We've looked at one of them is move, and the parameter is the distance forward you want to move. Negative will move you backwards. So if I put 4, I do 4 pixels every time this act method is executed. Now that's the cool thing about the act method, and another great thing in Greenfoot is that you can just push run, and that will execute the act method over and over in a loop cycle. And so that makes it really easy that you don't have to create a loop. It will just create a loop. If you push run, it'll create a loop that happens 60 times per second. And that's why you see 60 FPS, because frames per second. So basically it's going to run that and execute that, and every frame it's going to move forward 4. So that's a ton. So that moves, 4 frames, 4 pixels 60 times a second. Okay, because of each frame. Okay, now that I've minimized, it looks like I have a little bit too wide of a world. Let's do 500 here. See how that looks. Okay, that works a little bit better for me, but whatever works for you, you can make it as big as you want. We'll be able to change it up so that we can do kind of whatever we want with it. So the next thing we want to do is we want to add a bunch of these people in, and you can do that really fast, quickly, and easily by creating a function, public void populate, and this populate will allow us to add in the number of people that we want and populate the world. So in order to do that, the best way is to create a nested loop. And so for int I equals 0, while I is less than, and we need to have a variable that we can plug in, so that will be the population that you want to add in, and then I plus plus. So this will happen the number of times that you plug in for population. Now we haven't used population yet, we haven't created it yet, so we can do that, and I will make population default to 100, and we'll work with that for now. So what that will do is, if we look into our add object right here, this is a world method. If you were in a person, you couldn't add in another object, but if you're in the world, you are able to add an object. So what we're going to do is add in a new person. Okay, and so this will create a new person that has not been named. So we won't have a specific name for this person, and we won't be able to reference it, but we're going to have just a big population. So we're not going to reference individual objects. So it's fine to not do anything else here. Just create a person that we can't reference. Now the X value is going to be random, and so Greenfoot class has something that you can access. So if we do Greenfoot dot, we can do a get random number, and this is the limit of the random number, and that would be the width of the world. And so our world class actually has a get, remember control space, and to have this list pop up. Get width, okay, and we don't want to close that off there. We want well, we do want to close it off there because we do want to close off get random number. So you got the width, and then the width is a function, so it needs its own parentheses as well. So classes and methods both will have a parameter or an empty parameter if there's nothing in there. So Greenfoot dot get random number, and then control space get height is also there. And then once you have both of those, we're going to close off this add object method, which requires a object X location and a Y location. So that's why we're doing these random numbers. We're going to get a random number the width of the entire world, and we're going to get a random number the height of the entire world, giving us a random spot in the world. Okay, so that'll give us both a random X and Y, and I did not close off this add object. You can see Greenfoot, it's great. They'll highlight the parentheses for you so you make sure you're on track. And this populate is a method, but it's not getting added anywhere. So if we put it in the constructor, which is what we're going to do for now, and put in populate, this will happen when it's loaded. Similar to when person is added in, that's when it will scale it, not when it's run. This will happen immediately, which is great. So now we have our population, okay? But they just move forward. They don't really do anything. So we need to change that a little bit. So we're gonna have them turn, and you can have them turn, a certain amount. But what I like to do is do a random number for that, and so you can have them turn. If I just had them turn 4, and we did that real quick, you don't have to do this, but they'll just turn in circles. So it's going to turn clockwise if it's positive. We don't want it to do that. We want it to turn both left and right, and so I'm going to get a random number, Greenfoot dot get random number. Make sure you're camel casing, so Greenfoot's its own class, so it needs to be capitalized. That's where the dot comes in because it's referencing another class. It is our Greenfoot class that we have imported all the packages, which include all of these. So get random number, this is the limit, if you remember. So our limit needs to be, we can make it like 8, and so that'll make it turn, it seems like even more, but what we're going to do is we're going to minus 4. And then, so this gets a random number between 0 all the way up to 7. And so if you minus 4, let's actually make this 9. So this will give us a random number 0 to 8. If you minus 4 from that, it'll get us a random number -4 to +4. So that'll make us evenly go left and right. And so now when we play it, they turn a little bit. They do a little bit of movement. They're scooting along, but they might turn. If you want to have it increase more, you could have it be 19 minus, what would that be, 10, 9. So this would get you a random value 0 to 18, minus 9 would get you a random value -9 to +9. And so now you can see they're turning quite a bit more, and they'll even turn all the way around. Okay, another thing we can do to make them randomly be all over the screen is in our person class. I like to give it some space there. We can set a random rotation. So we can say set rotation of our person, and we're doing this in the constructor once again to happen before we start running the game. So it happens right when they're added in. Okay, and Greenfoot dot get random number once again, and our limit will be 360. So that'll give us a random value between 0 and 359 for how many degrees we want it to be rotated. Just right at the start. If you put it in the act method, it would constantly randomly point it up, then down, then wherever. Okay, all over the place. And so we don't want that. We want them turning a little bit more subtly, kind of like they're doing here. Okay, notice they all congregate towards the edge. We don't have them doing anything if they reach the edge of the screen. So we need to go into our act method, and let's go ahead and make a new function that is just for organization's sake, is going to be our movement. That way we can organize our turning and kind of how we want it to move, and we know all of this jumbled up together. So we got our movement, and we know, oh, there's something weird going on with our movement. We just need to go into our movement function. Okay, and so what we want to do if we are at the edge of the screen, so if we do control space, we can search inside of our pre-made methods for what we want. And so if we hit edge, so is at edge is what we're looking for. So if that's true, this is another thing you can do that's really cool is when you do control space, you can look and see what this will give you. If you're confused on kind of what's get one object at offset, what is that going to return to you? Well, it's going to return to you another actor. Just like we created person, this would return another object that's an actor that you created. Whereas get X or get Y will get our object's Y value. It'll get an integer value. Okay, this is at edge right here says it's a Boolean return type. It detects whether actors reach the edge of the world. Okay, so it's not looking at edges of people or objects. It's looking at if it's at the edge of the entire world. Okay, and it'll just return true or false. So if you don't put anything here, this will automatically assume true. You do not need to add in equals true. If you add an exclamation point in front, this would be false. So if is at edge is true. We are only going to do one statement, so you don't need curly brackets for this. You will turn, let's do 30 degrees. Now our act method doesn't have anything in it, so we could create all these different functions, but they won't work until you add it into the act method. And so we're calling our movement code. Now, like I said, we're a lot more organized. If there's an error and it's in our movement, we know we can go to this movement function because we're going to have a ton of code by the time we're done with all this. Okay, see now we're bouncing off the edge and it's kind of a free flowing, and when they don't flip around immediately, but they turn pretty darn quick. So that's a pretty nice effect, and it's not always flipping straight backwards. I don't know if I like that all that much when it does that. So that's good. Okay, so now I want to be able to say how many people I populate in. And so we're going to create a button. Go to right click actor and click new subclass and type in button. And I'm not going to give it anything yet. And so what we're going to do is we're going to go into our world, our my world, and we're going to move populate. And actually we're just going to cut it out for now, so it won't populate right away. So what I want to do is I want to create a act method for my world class. Your actors are, you're assuming that they're going to act or do something in the environment. The world class doesn't always do anything special at runtime. It's usually just a background and no reason for it to have an act method. But this will run 60 times per second, and we're gonna say if we click a button, we're gonna populate the world. So if Greenfoot dot, and we do mouse clicked on a certain object. Okay, so right now we have our persons class. We don't have any. We have our persons class, and we have all these new person objects. This is creating a singular object, but we're looping it based off the population of 100 that we've created. Okay, so there is no real object in here. But what we can do, since button is able to be accessed by my world, we can say button, something of the class button, and call it our pop button. Okay, and it's going to equal a new button. Okay, and so our new button, if it is clicked, if our pop button is clicked, we're going to have something happen. So we'll set up our if statement, but we're not going to put anything in it yet. We need to add in this specified pop button and reference it. So right away, I know when my world gets built, I want to have a population button. So I'm going to add an object, and it's going to be called pop button. Surprise. So now when we click on pop button, it'll be the same one that we've added in. And let's make it on the far left side of our screen here. So at 50, 50 usually is about the X and Y value of the upper left corner. And we'll see how that looks. Okay, so this Greenfoot, clever, is what's going to be covering up button because we haven't added anything as the button. But we're going to do that right now. So we're going to make a constructor so we can kind of build some things with it. Construct, if you will, some things with button. And so what we're going to have in here is we're going to access our image class once again. Instead of scaling it, we are going to change some things in it. We're going to get the image and we are going to actually set a color, and it's going to be a new color that's just transparent. So we're going to have 0R, 0G, 0B, and 0 for the transparency. Those are the four different parts of colors. You can also just have an RGB value and not have the transparency, but that transparency has to be 0 if you want it to be invisible, if you will. And so what we're going to do with that blank color is we are going to create we're going to set this image, set image equal to a new Greenfoot image that we're going to design entirely by ourselves, and I'll show you how. So inside of our API, once again, I'm going to show you how to get there. So you double click on your world superclass up here. It'll bring you to these packages. It'll bring you into the world superclass. I go to the packages. That's how I get to the API, and that's my way to do it. So anyways, Greenfoot image has the ability, if you create a new Greenfoot image, you can give it parameters. You can give it an X and Y value if you want to kind of just have it transparent, but you want a specific size. But what we're going to do is give it a string, a size, a foreground, and a background color. This creates an image with the given string drawn as text using the given font size. So this will be the font size, foreground, and background color, and this is what the string will be, what we're going to put in. Okay, so new Greenfoot image, string. Well, our string needs to be population, right? And what we're going to do with that is also add in what our value for population is. And so population, and then we're going to put a font size to that. That can be 30. And then we need to give it a foreground and background color. So my foreground color is going to be color.black, and my background color is going to be another transparent color. So a new color, 0, 0, 0, 0. Okay, and then we can see what that looks like, and it doesn't have the value population. Now, what we're going to do is we're going to be able to access this population by making it a static variable. So a public static int population. Since this is static, if you create a reference to my world, button will be able to access it because static is the same no matter how many objects you have or what class you're talking about. So you can reference it from anywhere because you're able to, there's only one. So it wouldn't be confused if there was multiple objects in. Okay, but in this case it's the world, so you definitely can access it by just doing my world and calling it world or whatever you want to call it. This is just a reference to the general my world class. And so when you do that, you can just do world.population and you're referencing my world, and since there's only one static population variable in there, you can access it anywhere. So if we undo this, population 100, no background, perfect, we're looking great. It's moved over a little too far. So when we add this object in, it shouldn't be at 50 for the x, we're gonna have to move it to 100 for the x. Okay, so we have our population. Now, I want to say, if we click the population, we will populate. But our population is something that I want to be able to manipulate and choose how much I put in. So I'm going to give this populate a parameter, int population. Yes, I know it's the same value as the variable we already created, but this actually is common when we're talking about the same thing. We're talking about population. This is the one that we're plugging in, the method that we're plugging in. This variable, population, is the reference to the world. So if we want to change our static population up here based off what we plug in to this parameter here, we need to do this dot population equals the population reference, the static population reference. If I change this, see, no errors. If I change this to pop, I could just change this to pop. So you actually can take out the this if they're not the same name. When they were the same name, you needed the this, but now you don't. Okay, so now we could go in and we could say populate 100. And so if we click our pop button, so if I click, it would populate my 100, and I could keep populating it and go crazy with it. Okay, but what I want it to do is I want it to ask me how much I want to populate it, not just automatically populate it 100. And so what we're going to do in here in the world class is create an input. And so you need to import something from Java, javax.swing.j option pane, and we need to get rid of this for now. We're going to have an integer that we will input. Okay, and if our population button is clicked, we're going to say input equals j option pane dot, and then you can do control space and see everything this j option pane has given us the ability to do, and there's all sorts of things in here. But what we're going to do is show input dialog, and we're going to ask show a question message dialog requesting input from the user. The dialog uses a default frame, which usually means it's centered on the screen. Perfect. Okay, and so we are going to have a message that says how many people in the world. So now I would like to convert this string input into a number, an integer value, so we can change population to be equal to whatever we input. So our population will equal integer, and Java has integer class that, and most programming languages have integer classes where you can do different things. Integer dot parse int, and we're going to parse, I guess not a quote for an integer, just input. Okay, so when we click on it, population will become equal to whatever we close in, and then we're going to have it populate our value that we've plugged in for population that we've set right here. Okay? Alright, so now we run, we click, how many people in the world? 300. And 300 people show up in the world. Now our population didn't convert here, so we need to go back into our world class. So we need to make sure that when our button is clicked, this world population updates. And so this is only updating right at the beginning. We need to copy, and we want this population to constantly be able to be updated. So now when we click 300, 300 shows up right there. Okay, so now they match. So now that we have a new image, we don't need this get image, set image to transparency. But what I would like to do is actually give this a background and actually give this a color, because it's not coming in as clear as I'd like. And so I'm going to just do a color dot white, and I'll copy and paste that, so when it actually is run, it also will show up with the color dot white. And keep the same amount of parentheses on both. Okay, now when we run it and I click, I put in 100, I can have these, and I'm going to actually have the population go on top of the objects that are getting added in. And so in here we can do a set paint order, and that can be our own method, or we can just do it as we go. I'm going to switch our population to start off at 0, since we're setting it every time we want to. And since this is one line and it's right here with the add object, and we want to just do it right at the beginning of our world, we can set our paint order based off of classes. And so here we could have our first class that will show up is our button.class, then our person.class. Okay, and that way our buttons show up in front of our person. Great, so the cool thing now that we've made the button class, I know it took a little bit of time, but now we have, if we put string name of the button, so string name, and we plug in name here, whatever value we plug in here will be the value that we use for our name. Now we need to change it up, because this is only local to this same function, the same method. So what we need to do is do string name, and we'd once again do the this dot name equals name, and so that will make sure that whatever we plug in the parentheses will now be stored in as the name and be available for this whole button class, and we'll use it boom here and here and constantly throughout, but we're not going to change it, so we can just set it once and leave it. So what that does is puts an error in our my world, and so in our my world we need to have a string, and now this is where we put the population space. Okay, we also, now that we've created this, we can create a infected button as well. This is going to be more like a label, because we're not going to do anything with this button except show off our how many we've infected. So there'll be a number next to each of these. So let's go ahead and actually clean this code up a little bit, get rid of the comment, space these out a bit. You can put things together and group them by what buttons they are or what they represent. And so I'm going to go ahead and collect population together, so I know this is obviously the amount of population, this is the button for it. So infected will have a number as well, but for now let's make sure that we add object infected button at, let's do 100 and 100 for the Y value, and we're also going to do a show text and access this population that we have, this number that we've inputted for our population. We're just going to put it right next to the pop button, so those match up. So you can just do 250, and you'll see us doing that with our infected button label as well. Okay, so this needs to be a string, and so we're going to have to put a fake string in there. We could put an extra space if we wanted to, but it's already should be spaced out enough. So now we go back and we reset. I have population right here. Maybe it doesn't look quite as pretty as it did before, but it'll be able to update once it's put in the act method instead of the prepare method. And so you can start it off there, but you also should put it in the act method after population gets set. Okay, so we'll run it, population gets set to 100. Now we have our 100, okay? And then infected. And the reason I made it a label, and I'll make all these labels, is because it's easier to see than this number. You could have had them both be the show text, but you can't really see it very well. Okay, now let's finally do what we're looking to do, which is infect the objects. And so we're going to need to have void infect. And so this is what the reaction will be if you are infected. So here we're going to draw a way to signify that you have been infected. So you could upload an image of sorts, but I have a couple ways to do it. That'll be a little bit faster than importing an image and setting that as an object. So we can just draw on here a red cross, 5, 0, 10, 20, and quickly copy, and we're going to make another red rectangle that's at 0, 5, 20, and 10. And then we're going to have to change a variable that we're going to need to create that will be called infected, and we'll set it equal to true once we infect. And so here we're going to create our first variable in the persons class. Let's get rid of this comment, and let's go ahead and put public static boolean infected equals false to start. Okay, so now that we have that in there, if we go in and actually run our simulation, they won't contract the virus, but I can pause, infect, and that's what it's going to look like. So they have a little badge that has a cross, and then this will turn green when they are over the illness and they have healed. So if we go back in, and we are going to need to find a place to implement this infect. So when are we going to infect another person? Well, when they are inside of a certain radius and we're close enough to them, they will become infected, okay? And then we're going to move and try to make them avoid each other eventually and do social distancing. Then we'll put a mask on to shrink the radius in which they will infect someone else, so that it's a little bit harder, demonstrating the fact that if you put a mask or gloves on, it will lower the infection radius. So when we go into person, we need to find a radius around this person. So if I just went, and we'll create a method that sounds like contract virus. So this is how you contract the virus. And so I need to have that radius. And in order to get the radius, we can do control space. And you can get and look through the get, because we're trying to access objects within a certain radius. And so get objects in range requires a radius parameter and a class. In order to bring this up, remember it's control space, and you can get this list pulled up. So yeah, we're going to do that eventually, but we need a way to store all the objects that are in a radius, because there's going to be, eventually we're going to have a radius to start us social distancing, and you need to be able to know multiple objects in your radius, because there could be 8, 9, 10. We could put 1,000 people in the simulation, and we would need to be able to see different people within our radius. So we need to handle that by creating a list of the person class. And so what a list does, it's different than an array. An array is a set number of objects or different data types. A list in general doesn't have a set number of objects it will access. It just creates a list of all the objects. Okay, so we're going to call this people, because this is all the people that we're going to get. So equals get objects in range, and we're going to eventually have this be able to change, so this will need to be a variable, but to start we'll put it at 20, and so it'll access any person. So this object person, so whatever any individual one you could look at in the world, and it would be able to do this. It would list all the people that are in the range of 20. Okay, so then we can cycle through this and read each person, and I'm going to call it this one person of list people. So it says whichever person in list people. Okay, so all the persons in list people. So I'm actually going to change this to persons. Okay, so that cycles through all of them, and we can just say for now infect. Okay, and that will make it so that any person that walks in there will be infected. Okay, now that we have that, we need to make sure we put it in the act method. Then you run it, and a lot of them already start within the range of something else. Okay, so if we decrease this down to like 10, not that many people have it right now, but they just, they start with it. And so when you have a few start with it, because if you start within a range of someone else, that will happen. Okay, but if I had less, people wouldn't start within that range. So in order to do that, we don't want to infect anyone in the range of anyone else. Another person has to give the virus to someone else that is infected. So we would have to say this Boolean infected would need to be true. So we would do if infected was true. So really all you need to do is do if infected, we will infect someone else. Okay, and so not if this person is infected. I've made a mistake. You need to check that the person that we read within our vicinity, persons dot infected, then infect someone else. So now when I run and I put 100 together, no one is infected to start, because even though they're in the vicinity, no one else, they have to also be infected because we just switched that. But if I add in an infected, you can watch, and a ton of people. Now here's the beautiful thing here is I made another mistake, is that a ton of people are getting infected all at once, because if it's static, it's not for each individual person whether they're infected. That would mean all the people in the world are infected. So I need to take this out, and I need to rerun it. And infect here, and then when I run it and I run into these people, you see the infection spreading. Okay, and this is how we want it to run. But we also want a heal amount of time to heal, and we'll have some social distancing stuff. So here, if the person you run into is infected, it will infect you. The problem is we're continuously infecting ourselves over and over again. And so in order to have a recovery time, we also need to say and infected equals false. And that means we are not infected. So we have to not be infected in order to get infected, and the person that we run into has to be infected in order to infect us. We can add a curly bracket to this, and we need to switch our infected equal to true. Okay, so that hasn't changed anything specific for us yet, but allows this only to happen one time. Okay, because the person will switch from not infected to infected, and so they will only be infected once. And so what that will do is increase our infected amount. And so what I want to do here is I want to add in a way to reference the infected, well, a number for infected. And so public static int num infected, and we're going to start that equal to 0, and we are going to show text at x is 200, y is 100. So now we need the number infected to go up, and so we need to be able to access this static int number infected. Easy way to do that call the class myWorld and access a static int in there. And so you can reference it, because since it's static, you can just call any old myWorld and call it whatever you want here as the name and reference that static number. World.num infected plus plus. And you need to not only add this in your constructor, but you also need to show text in the act method. Just like show text for population, you want to show text for, and this is a problem here, it's called population up here too. Num infected, num infected. Okay. $100. If I infect someone, this count goes up. Okay, and see, since I infected someone without the program running, didn't count my first one that I added in. So that'll be something that just kind of happens that we'll fix here in a second. So since these are static, you have to recompile in order to get rid of these numbers. So if you want to, but now that we know that it works, we can continue on. So after a certain amount of time while they're infected, I would like these people to be able to heal. Okay, and so in order to do that, I'm going to say if infected basically is true, we're going to have a variable add up to count how long we're infected. And so I'm just going to say int recovery time and set recovery time equal to 0. We're starting off our time at 0, and then recovery time plus plus. And then we could say if recovery time is greater than or equal to 200, we are going to heal. We don't have a method for that, but we'll create that. And infected will now equal false. We are no longer contagious. So now we need to create a method for heal, and we're going to use, instead of we're just going to use a green color to mark that we have healed. So healed is probably a better term. Will be green. So we won't include infected equals true with healed. Our infected will have already equaled false right here. Okay, but what we will do is we will have a button that will be healed. And so if we go into our myWorld and we add public static int num recovered equals 0 to start, button recovered button equals new button recovered, and we can copy, paste, recovered, recovered, 200 and 200. We'll do 150, 150. So instead of having our number infected in here, we're going to go ahead and put it in our infect. Okay, so we're going to take number infected out of healed, and we're only going to have it when they get infected that one time. Now we need a number recovered to be accessed right when they heal. So world.num recovered, and our world.number infected should minus minus. Okay, and then we need to make sure that our infected needs to equal true, so that this healed only happens one time. And let's go ahead and set recovery time equal to 200 so that recovery time will just stop and this won't happen anymore. All right, down here we have infected equal false after they've recovered, and so they wouldn't be infected anymore, but what that actually does is make them vulnerable to being reinfected, and so we don't want this in here, and that will allow it to turn red and then turn green, but stay green. So they would stay healed. So my number recovered needs to show up in the text as well. So I have it needs to be in the act method as well. You could quickly create a num vulnerable, and all you'd have to do is do math vulnerable lowercase v, and call this vulnerable, and these would only be the ones that haven't been infected and haven't recovered. Okay, so in your entire population, how many have not been infected, essentially, because those are the ones that are vulnerable. So all you'd have to do here is do show text plus num would be population minus num infected, and you can put it at 200 comma 200 because this is at 150, so we keep going up by 50, and we would just have to add in a new object that we just created. That would be the vulnerable button. Okay, now lowercase v. Okay, and we need to make sure this is in parentheses so they know that it's an equation connected to a string here. That was silly of me. Okay, so we need to make sure it's low enough, I can already tell, and that it's in the constructor as well. Add object, yeah, see that's at, so that needs to be at 100, 200, and this should be at 200, 200. Okay, perfect. We also need to include the number recovered because whether you're recovered or you're infected, you're not vulnerable anymore. So we'll do number infected plus number recovered and add those two together first, and then we'll subtract both of those from population. And we'll do the same thing here. Plus recovered. Compile. And we can test that. We have 100, 100 are vulnerable. And if we infect, that goes down, and it also goes down when they recover. So that means one person's left to be vulnerable. Okay, now 100 recovered. There aren't any more that are vulnerable to the virus, and none are infected anymore. Okay, so now we're going to create a social distancing button, and so we'll copy and paste, but this will be a Boolean, and this will be social distancing. Social distance equals false to start, and we'll have a social distance button, And we're going to say if we click on the social distance button, we are going to switch the Boolean social distance is going to equal the opposite of what social distance currently is. So it'll start off as false, you can switch it to true, and you can just click that back and forth and it'll switch. Now when we add our object in and we move it, add object, social dist button, make sure your parentheses are on point. Okay, this needs to be at 100 and 250, and this will be at 250, and it will be show text, and the text will actually be another variable here, and that will be social distance, and we need to show text in the act method. So when we run it, we can click social distance. Okay, and we have a variable that changes. So let's move this out a little bit further. Also move it out a little further in the act method. And we run it. You can click on true or false. But now we need to have the people actually do social distancing. Okay, and so similar to reading if there's a person in this range, we're also going to do the same thing for reading if we're social distancing 6 feet away. Okay, and so to get that started, you want to, let's go ahead and just copy this. Okay, and we're going to go into public void social distance, and actually this is going to need to have a parameter. And this will be a Boolean parameter, checking whether we are social distancing, whether we've set it to true or false in the world. And so we'll put Boolean enabled. So are we enabling social distancing or are we not? And so in order to do that, we can paste that list that we just copied. And we can actually use the same variables since these are two different methods. Now at about 60, I'm going to read for any person in the field in a range of 60, and if there is, okay, and here's how we access it the same way, and if this is true, I'm going to have myself turn, and we'll start off turning 5. If this is true, we will run it, and so we need to put social distance, and we need to put whether it's true or false, so we can access the world and access that true or false Boolean that is called social distance. Okay, so now if this is true, we will practice social distancing. We can put if enabled, we will do method. Okay, so if enabled is true, we're going to do all of this. You can also do Control-Shift-I, and that will kind of push everything out and organize your code a little bit better. And so this is going to do social distancing, and if this is true, we are enabled and we will do it. So we should run population of 100, and if we click, you can see they start doing social distancing. Well, they start turning, at least you see them start turning in circles here and then here. Okay, so we'll go back into person, and we're not just gonna have them turn 5, we're gonna have them do more than that. So instead of turn 5, we're going to use a random number, greenfoot.get random number, and we're actually going to do a little bit stronger of a turn, but since it's both directions, it won't be as drastic of a change as you might think. and we run it, and with 50 people, we use social distancing, and we infect, and this might infect both of these. Nope. Okay, so they kind of move out of each other's way, and with 50 people, there's 3 people infected, 1 person left infected, 0 infected. Everyone's recovered. There's 3 recovered, so that just put it out. Compared to if I did 50 and I didn't do social distancing, let's restart. So if I compiled, run on population, we can do 50 without social distancing. We've kind of seen that before. We can infect, and you can see that even if it starts off slow, eventually it'll infect most of the population there. Okay, so let's go ahead and do that mask. And so we can do something very similar to how we did our social distancing. So we can go over the same way, copy, paste, mask on, and we'll call it mask button, mask, and then we can copy, paste, mask plus mask on, switch our Y value to 300, Y value to 300. See what that looks like once we do show text in the act method. And if we click on mask, we want mask on and mask on in these 2 spots. Just want our mask on to switch from true to false when we click it. Okay, we got that set up. We go to our people, and you can access the if mask on is true. If mask on is true, we are going to set our infect radius, which we're going to create infect radius equal to 20. And if mask is on, our infect radius will equal 10. And this will be infect radius mask on. So the way we get our mask on is from our world dot mask on. If we go to our my world, that is where our mask on is available to us. So let's run it, mask, social distance. We put in 50. We can infect, and then we can inspect. Then with our inspect, we can check what is our infect radius. It's 10, so that means we really shouldn't infect people unless we run right over the top of them. And that makes it so the spread is very, very slow and difficult. And so you can always increase social distancing if you'd like. Like if you changed your social distancing number, or the level of social distancing went up for, you could make up any reason in a simulation. But if you pushed it to 90 and you social distance, it'll be very hard for people to kind of touch each other because they're so far away. They start turning and twisting and contorting from such a far distance that you won't see them run into each other very often. And you can infect, and you can see it's very unusual for someone to infect too many more people. And you can see the slow of the spread. Okay, if anything, it just makes people slowed way down. Now we can actually lower our infect radius down to 1 just so we know that it's working. And we can make an image and draw an image. So get image dot set color, and we're going to draw a little mask on our person real quick. Color dot white, and you can get image. There's only 2 lines of code here, so dot fill oval, and you can make it 14, 5, 10, 4. Comma. There we go. And then if we put in 100 and we throw a mask, each one of them will have a mask on, and you can see that just covering their face here. Okay, so then when you flip it off, it'll be false. So we need to switch that back to if it's not on, if world.mask on is false, we can do the same thing, copy, paste, but we'll make it black. And if it overruns, we can change that a little bit. But basically, mask on, off. There we go. So you can see the difference. And we did social distancing, and if we pause and we infect someone with that low of social distancing, they might not even infect anyone else. You got to be very, very close to someone, and you can see how the population has a much harder time of getting infected. Okay, there's one infection from another. Okay, and you can see the infections just are very, very difficult because people are practicing correct forms of social distancing. So the last thing we can do real quick is just have a time variable. So if we just create int time, and we can have this time add up 60 frames per second, and we can have show text plus time divided by 60 will be 1 second, and we can actually put time colon space, and we can put that at the top of the page. So we'll put it at get width divided by 2, so we could do that, or we can just do 600, and we'll be at 50. So you can just copy this, put it in the constructor as well, and now you can run your program and it'll start counting for you. Just be ready to put the population in pretty quickly, and you can see that if there's even 300, but if they practice social distancing and wear masks and you infect, they still will really have a hard time infecting someone else because of that radius of how much you can infect is so low. So let's say people weren't wearing masks, but they were social distancing, and you infect, even if you infect a couple people, it won't do near the effect that the masks will. So you see it starting to spread. If we put masks on everybody, I bet you it dies out. You can do a bunch of different simulations. There we go. You can do a bunch of different simulations in a bunch of different ways, but just know that, I mean, we don't have to have it go all the way down infection rate to 0. You can always change that yourself. But I hope you guys not only enjoyed creating this simulation, but kind of learn what the effects of social distancing can have, and wearing masks and wearing that proper protective equipment when you go out in public to prevent the spread of the coronavirus. I highly recommend you challenge yourself to do something on your own now that you've gone through this video. My challenge to you would be make another button that would be gloves, and you could increase the amount that the infection radius goes down. So maybe it starts at 20 if you social distance, or excuse me, if you have a mask, it'll go down to 10, and then if you wear gloves, it'll go down to 5 or 1 or something like that. And also having a reset button. Try to get a reset button that you can make, and then you can just have these values go to 0 inside the world class. Really shouldn't be too tough. It's all things that we've kind of worked with already in this video. So I hope you guys enjoyed. Until next time.